Okay, so welcome to our very first class on differentiation by first principle. We're now diving into calculus, right? So I want to take this class to break down what the first principle formula means, how we got about that formula. Before then, let's look at what slope is. Slope of a straight line. I want to explain what slope of a straight line is. Now look at slope of a straight line or gradient of a straight line speaks of how steep a line can be. That speaks of how fast a line can rise or fall. What happens when a line rises and what happens when a line falls. So slope of a straight line, let's assume this is our y-axis and this is being our x-axis, right? And let's take a line moving from here down like this. Are you getting a straight line? Although it's not drawn to scale, so just bear with me. And let's assume that our reading from here is 1, here is 2, here is 3, here is 4, here is 5, here is 6, here is 7, and here is 8 for the x-axis. Also for the y-axis, we have 1, we have 2, we have 3, we have 4, we have 5, 6, 7, and 8. If we are asked to find the slope of this line, let's take points, because as the line rises, it breeds points at every area. So let's take here as our point 1, or let's call it our point A, and let's take here as our point B. We want to calculate the slope between point A and point B. What does it really mean? Look at at this point A, at this point, the x-axis is 2. Are you getting it now? And let's assume that this is our y. Let's assume this is our 3. And at this point, the y-axis is 3. So the first point, that is at A, x is 2 and y is 3. That's at point A. And then at point B, what happens? At point B, we have that B is 4. And y is what? Let's assume that y is, let's take here to be 7. Let's assume we have 7 here. This is 7, right? Y is 7 because it's not drawn to scale, right? That means at point B, x is 4 and y is what? Is 7. If we are going to look for the slope of this, the slope is simply, the formula is simply the change in y, which is y2 minus y1 over x2 minus x1. That's what slope means. And what is y2 minus y1? Look at, this is the first x. Let's call this our x1, and let's call this part our what? X2, right? And this is our first y. Let's call this our y1. That's because it's the first one we made, right? And this is our y2. Let's call this our y2. Are you seeing now? And then slope is what? y2 minus y1. That would be what? 7 minus 3. And between y2 and y1, it's a change. They call it a change. It's called delta. This is a triangle. Delta y. It's a change. The line is changing from 1 to 2. So this is delta y. Also, between here and here, it's experiencing a change called delta x. Are you seeing it now? So I can change, my slope can also be called change in y over change in x. That's what it means. So if we are doing our slope for a straight line is simply the y2 minus the y1 over the x2 minus the x1. So our slope will take this form from here to here, becomes our slope. Angle, right angle triangle. Are you getting it now? This becomes our slope. This one becomes our slope. This line. Are you getting it? So what's our y2 now? y2 is 7 minus y1, which is 3, minus 3 over x2, which is what? 4 minus y2, whereas x1, sorry, which is what? 2 minus 2. And then 7 minus 3 is what? Is 4. Also 4 minus 2 is 2. Therefore 2 here is 1, 2 here is 2. We are safe to say that our slope, which is change in y over change in x, is equal to what? 2. This is the slope for this line, for this diagram, right? That's the slope. That's how to calculate slope. Slope for a straight line is y2 minus y1, and y2 minus y1 means the change in y. Also for the x-axis, it is x2 minus x1, and x2 minus x1 means the change in x, right? So if I are asked to look for slope in a straight line, So for any straight line, you just go and say the slope is what? Is the y2 minus y1 over the s2 minus s1. That is the change in the y-axis minus over the change in the x-axis. Change in the y-axis is the y-axis over the change in the x-axis. That's simply what the slope for a straight line is. But then we are looking at slope for what? For a curved line. And there's something that happens when we are doing slope for a curved line. What happens? Now, having known what the slope of a straight line is, let us look at what the slope of a curve means. It is the understanding of what the slope of a curve means after comparing it with this is how we'll gain our understanding on what first principle differentiation means. Now look at now. For a curved line, let's assume that our line is a curved line. Assuming it's a curved line, there is no way we are going to find the slope at a point, right? There's no way we can find the slope at a point without looking for the tangent first. For a curved line, we're only looking for the slope at one point. That is the tangent. That is where we draw a straight line. This is called a tangent. The tangent is a straight line that cuts across, that meets this curve. Are you getting it now? So our job is to look for the slope at this point. Are you getting it now? And so it's at this point we can now start finding, let's say our point here, which meets with here, right, as our A, and then we cannot find another point here which meets with this other side, and here being our B. So let's assume now, let's assume that here is 3, our x-axis is 3, and here is 6, and also our y-axis is let's say 2 for instance, and here is 10. That's for a curve. Now for a curve, we don't just go and pick 2 points on this curve. No, it won't work. What we do is first of all draw a straight line that meets at a point called a tangent line. This straight line is called a tangent line. It is from this tangent line we will now take our slope. Are you getting it now? From this tangent line, if it has to do with the straight line, we just take a straight line and take 2 points and then find our slope. But not so for a curve. If we are given a curve on the graph, what we do first for a curve is to take a line that meets at the edge. This is the point whereby this line meets this curve. Right now, from this point, we start picking our 2 points. From this line, we start picking our 2 points and then finding the slope. And we know what slope is now. Slope is simply the change in y over the what? Over the change in x. I just said it just now. So our slope from here becomes y2 minus y1 over x2 minus x1. What is y2 minus y1? Y2 minus y1 is simply the change in y. That's what I said. The change in y over the change in x. You see how slope for a curved line is formed? That becomes, what's our y2? This is our y2, 10. 10 minus y1, which is 2, over for this one, x2, which is what? 6 minus 3. And so our slope is what? 8 over 3. You see, because we can't divide further. So our slope is giving us a fraction. Now, you can take it, if you do this, it will be 2 point something. Are you getting it now? So for this is just the slope for a curved line. I tell you, for a straight line, we just take our straight line and then find the two line meeting, right? 2 points meeting in the line and then get our slope. But for a curved line, we'll first of all draw a tangent that meets this curve at a point. This is a point. It meets it at a point here. Are you getting it? And then from this our straight line, I will now start picking 2 points on the slope. That's for this. You see the difference between this and this now. So to that, let's bring our understanding to what the slope is for first principle of derivation.